By the end of this lesson, you should be able to relate buoyant force to the weight of the liquid displaced. State the Archimedes principle. Why can a swimmer float more easily in salt water compared to fresh water? Let's find out the relationship between the volume of water displaced and the density of the liquid. Drag and drop the cube into one of the beakers. Observe the cube and the water level. What can you say about the volume of fresh water compared to the volume of salt water displaced by the cube? The volume of fresh water is greater than the volume of salt water displaced by the cube. The cube floats higher in fresh water than in salt water. According to Archimedes' principle, for the cube to float, it must displace a weight of liquid equal to its own weight. Fresh water is less dense than salt water. Thus, the cube has to displace a bigger volume of fresh water compared to salt water. If density of fresh water is ρ1 and density of salt water is ρ2, volume of fresh water displaced is V1 and volume of salt water displaced is V2, we know that ρ1 is less than ρ2, and from the observation, V1 is greater than V2. Let's determine the relationship between buoyant force, density, and volume of liquid displaced. A cube floats in water with a density of ρ. We know that the pressure acting on the bottom of the cube, P2, is higher than of the cube, P1, due to the depth of the water. What are the forces acting on the cube? From the formula, P equals F over A, force acting on the top of the cube, F1 equals P1A equals ρh1GA. Similarly, force acting on the bottom of the cube, F2 equals P2A equals ρh2GA. What is the net force acting on the cube? Net force acting on the cube F equals F2 minus F1 equals ρGAH, where H equals H2 minus H1. Since volume V equals A times H, is the volume of cube which is equal to the volume of the water displaced. Therefore, F equals ρGV equals ρVG equals mass of water displaced times G. Buoyant force F equals ρVG equals to the weight of water displaced.
Let's carry out an activity to determine the relationship between buoyant force, density, and the volume of liquid displaced. Choose the value of density of water. Then click on the Start button to begin the simulation. click on the correct answer. An object is floating in a beaker filled with oil, and its cross-sectional area is 4 centimeters squared. Calculate the buoyant force acting on the object if the level of the oil displaced rises 10 centimeters. Density of oil equals 0.8 grams per centimeter cube, and G equals 10 meters per second squared. A metallic cylinder is submerged in a liquid as shown in the picture. Which of the following statements are true about the relationship between the upward thrust and the density of the liquid?